So students, we are going to discuss an important approach for competitive exams. That's a shortcut approach, in fact, useful in the competitive exam, any competitive exam, for 3-dimensional geometry, which is based on finding out the length of perpendicular from a point on a line given to you in a symmetric form. So I take that approach using an example. Find the length of perpendicular. The question is, find the length of perpendicular from the point 1, 3, 7 on the line, and that line is given to you in the symmetric form. X minus 3 by minus 5 equals to y minus 2 by 5 equals to z plus 7 by 2. Length of perpendicular find out करना है आपको, and that's a shortcut method. Now look how it's happening. Let's say that point is given to you, that is 137. Line is also given to you in the symmetric form. This Pn is nothing but the length of perpendicular. From the point you have dropped a perpendicular there, n is the foot of perpendicular there, and Pn is the length of perpendicular, and we are interested in the length of perpendicular. Directly to calculate length of perpendicular, what you are going to do here, just observe here, Pn square, which is nothing but the length of perpendicular and its square of that. That is nothing but 1 upon minus 5, 5, 2, these are the direction ratios of that line. So 1 upon minus 5 square plus 5 square plus 2 square, and then the line which is given to you in the symmetric form, we are going to express it as a square of a determinant of order 2 by 2. Look how we are going to do this. X minus 3 minus 5, y minus 2, 5 plus y minus 2, 5, z plus 7, 2, that determinant square, plus it is x minus 3 minus 5, z plus 7, 2, and that determinant square, right? What you have done here, Pn square, length of perpendicular and its square of that is 1 upon minus 5 square plus 5 square plus 2 square, which is nothing but the sum of squares of its direction ratios, and then 2 by 2 determinants are there, equation of line which is there in the symmetric form, 2 by 2 determinant form में उसको आपने express किया, and square of that, summation of that. Now the point is how it is coming. It is through the projection formula, and in projection formula that those direction ratios are required to be converted in direction cosines, and that's why it has been divided by like this. So how we are going to solve? In place of x, y, z, you are going to keep x equals to 1, y equals to 3, and z equals to 7. 2 by 2 के determinant में express किया गया, squares of that, sum of that, and now you are going to keep x equals to 1, y equals to 3, z equals to 7, Pn square. That will be 1 by 25, 25, 4, 54. In place of x, 1 minus 3, which is minus 2, 3 minus 2, which is 1, 5, right, plus 1, 5, 14, 2, plus minus 2 minus 5 and 14, 2, and square of the determinant. So Pn square is equals to 1 by 54. We can calculate this determinant easily. That's a simple determinant of order 2 by 2. Easily it can be calculated, which is nothing but minus 10. It is minus 10 plus 5, which is minus 5 square, plus it is 2 minus 70, which is minus 68 and square of that, plus it is minus 4 plus 70, it is minus of 66 and square of that. We can calculate these values, divide by 54, you are going to get Pn square. Yes, you will have to remember that what you are getting is the length of perpendicular and square of that. So finally you will have to take the square root to find out the length of perpendicular. Do take care of this fact. right? But what is happening here, that without finding out the foot of perpendicular, we are able to calculate the length of perpendicular. That is an important point, because the usual approach is what? In usual approach, you are going to take that symmetric form of the straight line equals to r. You are going to get a general point. Then general point, let's say that general point is equals to n in terms of r. You are going to calculate the direction ratios of p and then x2 minus x1, y2 minus y1, z2 minus z1. And then you are going to apply a1, a2 plus b1, b2 plus c1, c2 equals to 0 using these two lines are perpendicular lines. And then you are going to find out the value of r. And based on the value of r, you will be getting the foot of perpendicular. And after finding out the foot of perpendicular, you will be calculating the length of perpendicular. But what is happening here? Directly we are getting length of perpendicular. Without taking the help of foot of perpendicular, we are getting the length of perpendicular, and it is useful for any competitive exams. You can directly get the length of perpendicular.